Welcome back to the Automation Podcast. My name is Shawn from Insights in Automation, and I hope you're having an awesome holiday week this week. If you celebrated Christmas on Monday, I hope you had an awesome Christmas. And no matter what you're celebrating, I hope you're enjoying time with friends and family this week. And I also hope you have a great New Year's Eve and New Year's Day. Now, I'm on vacation this week, a little getaway with the wife, and I still, though, wanted to release an episode of the podcast. So what I did here is I went back to my Trends in Industrial Automation session from the Siemens event in November, and I re-listened to the whole thing and then re-edited it. And I'm now releasing that as this week's episode of the Automation Podcast, and I think you guys will really enjoy it. We're releasing it both on video and audio, like we do every week. And I think you guys will really enjoy that. But before we actually jump into that, I do actually have two announcements. First of all, I want to thank our sponsor, theautomationschool.com, for covering our costs to produce this episode. And I also want to mention that I'd really like you guys to head over to theautomationblog.com and vote in our first ever Audience Choice Award polls. So starting last Friday and going through this Friday, we are having a poll every day except for Christmas, asking you what your favorite products are and who your favorite vendors are. And this is going to be so helpful for me as I look forward to 2024, to know which vendors you guys are using and which products you like, so I can know which vendors and which products we should be having on the show. So if you get a chance, please take a moment to vote in our first ever Audience Choice Awards for 2023. You can vote up until January 1st in all of the polls. And it would really be a huge help to me if you could get up there and just vote in some of those polls and let us know who are your favorite vendors and what are your favorite products. And there's even a space on each poll where you can add your own selection. If you don't see your choice there in the list, you can add it yourself. So with that said, let's go ahead and now jump into Trends in Industrial Automation. Welcome to the Trends in Industrial Automation session. My name is Shawn from Insights in Automation. And in this session, I want to share with you several positive trends I've been seeing in our industry. Now, as the host of the Automation Morning Show, every morning I'm reviewing over 200 automation websites to learn what's new and happening in our industry to share that with the audience. And as the host of the #1 product and technology show in industrial automation, the Automation Podcast, every week I have the pleasure of sitting down with a new vendor and new product manager to learn about the exciting new products and technologies they're bringing to the market. So it's from that perspective that I want to share with you several positive trends I see happening in our industry. Now, you hear a lot of people talking about connectivity and digitization, but I don't really see that as a new trend. I mean, we've been networking control systems together since the late 70s with Profibus, Modbus, Data Highway. So yes, these devices now over time produce more and more data, and we need faster and faster networks. And you'll even find gigabit Ethernet products on the plant floor today. But what really impresses me is this trend to new features, right? The capabilities of the products are growing and growing. Take, for instance, the S7-1500. Recently, Siemens released the View of Things feature, and that allows users to design dashboards and simple HMI displays and actually download and run them right on the PLC. Now, don't take my word for it. Let's actually see Louis Navaz of Siemens do it in a clip from a recent episode of the Automation Podcast.
To illustrate, I'm going to just drop in a gauge. The nice thing is this is all SVG, right? Scalable vector graphics. So even if I have different, it's resolution independent. So depending on what browser I'm using or what the resolution on my screen is, the objects will adapt to the browser settings. So even if I'm on a smartphone, for example, I'm going to add an IO field, and let's put a text box above that, and let's change this text to output. So it's kind of redundant, but I guess it doesn't really matter. All right, so how do I add a tag to these objects? So there's several ways. I have a HMI tag table, and I can browse to my PLC tags from here. But I'm going to go to my screen, and in my program blocks folder in my PLC, now I've already got a program set up here. All it is just a sine wave function generator. It's nothing fancy. And with that sine wave function block, there's always an instance data block, and with the data block, I can use those tags there. So I'm just going to take my value tag from my data block and just drop it on the object.
Nice.
So I've dropped it onto this, so I've dropped it on this gauge. I'm going to drop it on this IO field. Actually, maybe I should just rename that to value. And now we're ready to download this, right? And that's it. So we've got our application running.
Now, it's not just the PLCs that are getting smarter. It seems like everything in our control panel is getting more and more features. Even the motor starters. Take Siemens Simicode, for instance, as described by Mark Berger in this clip.
So here's with the Simicode, we're just going to show you kind of a standard cross-the-line starter application. You can see here that we've got a flow, valve, a filter, and we're measuring delta P across it. And then we have another valve, and then we got a tank with some sensors for lower and upper, and then also a float to tell them where approximately it is, and so forth and so on. But this is just an application of a standard starter. And if you look at it, yeah, it's an IEC starter. You can interject a NEMA starter here if you would like. But really, it's trying to emphasize that you're not getting any really major data to help you. And as you know, data is king nowadays. And I know a few major applications out there that are looking for data right down to the IO point. But what we have here really is just an overload relay protecting the motor. And yes, you may have a sealing circuit or a contactor telling you that the 3 phases are pulled in and saying that it's running. But then, of course, you see the flow, so that tells you that the pump's operating and there's no coupler problem between the motor and the pump. And then you have a delta P, and that's coming in, but it's going to all this IO that's out there. Now, if I introduce the Simicode, what can it give us? It's going to take over all that IO. And again, I'm kind of pushing this to the Simicode's limits. It's reaching that with an analog module so I can see the flows coming in. Again, we're not controlling them because it's a cross-the-line starter. And then I'm able to see the delta P. And then I put a digital module, and now I can see the digital ins of the tanks, and I can do an output to that valve to open or close. And now the Simicode is taking care of that entire application directly to the Simicode. And now it'll be able to do a standalone if it needed, or it can continue to contact the PLC and give all the information that's going on there in that application. And then one last extension of that is the safety factor. So we can do safety depending on your application, but we can do any of the safety that is required with your plant. If you're using the safety specifications for SEAL, safety integrated level, SEAL level 1, 2, or 3, or if you're using the specification for performance level, A, B, C, and D. I'm able to do that locally and with third-party PLCs, or with a Siemens safety PLC, we can do Profi Safe.
Now, all these new features are great, but to actually utilize them, you need the device to speak the same protocol you're currently using in your control system, and that's one place I'm seeing a very promising trend. Several companies are now producing products that speak multiple protocols right out of the box with no modification and no gateways. You know, it could be distributed I/O, it could be a VFD, it could be a weight scale, it could be a signal conditioner, or even a compressed air management system, as seen in these clips from the Automation Podcast.
We also introduced a new interface module. We call it the multi-field bus interface module. So we released this interface module that is capable of communicating in Ethernet IP or Modbus TCP or Profinet.
And the benefit of our drives is that you can switch between Ethernet IP and Profinet with just one parameter change. So on this slide, I have a bunch of different Siemens products, including our HMI, our PLC, our IO, as well as our drives. And they're connected on both Profinet as well as Ethernet IP.
Here's my favorite slide in the presentation. Not only do you get the web interface, but you get an automation interface. So we connect to Profinet, we connect to EtherCAT, we connect to Ethernet IP, CC Link IE, Modbus TCP, and Modbus RTU, and Profibus TP. All those interfaces are certified.
The DXM R90 industrial controller is what you see here. You push that data from all these different sensors to the cloud, whether that's AWS, for example, or Banner's own cloud, which is called Banner Cloud Data Services. We could also send that data via that decode Ethernet port to your PLC or your SCADA. It talks all those industrial languages, Modbus, TCP, Ethernet IP, and Profinet.
Really convenient part for me as someone who demos this hardware is the BM40IE device is capable of doing all of the industrial Ethernet outputs, your Profinet, EtherCAT, Ethernet IP, Modbus, TCP. You don't need a different device for each of these industrial Ethernet buses. You can just change what bus you want it to operate on from the web server, and you're good to go. You get your ESI file, or you get your ESD or your GSDML, whatever matches your bus. You generate that from the web server, put it into your system, and now you're working on a different bus.
Now, I'm not going to argue about the utility of Ethernet, right? Any computer worth its weight comes with a physical Ethernet port, and most electronics have Wi-Fi built in, right? And man, it is nice not to have to worry about these expensive ISA and PCI expansion cards anymore, or to have to carry around bulky serial converters or fragile PCMCIA cards. But not every device is suited towards Ethernet. Take a PhotoEye or an inductive prox. Typically, the cost to make those products is 1/3 the price of an Ethernet chipset. Yeah. So there's a better solution for those simple devices, and that's I/O Link. It's like the USB of industrial automation. And don't take my word for it, though. Let's hear from Michael Brown from PI North America in this clip from the Automation Podcast.
For audience who may not be familiar with I/O Link, it's a sensor level communication protocol. So it sits below the I/O and speaks from what's known as an I/O Link master. So an I/O Link master kind of works, I guess you could call it a gateway, but so on below it speaks I/O Link to the sensors and actuators below it, and above it speaks usually an automation protocol like Profinet, for example. But it's also, I should stress that it's field bus independent. So I/O Link, even though it lives in PI, we don't place any favorites on I/O Link when using it with Profibus or Profinet, because it also works just as well with every other field bus and industrial Ethernet protocol out there. And the reason, for those who want a little understanding of why I/O Link makes sense, is because you're not going to put a $15 Ethernet chip on a $5 proximity sensor. That just doesn't make any sense.
Yeah.
Sure, if you wanted to get that extra rich data, sure, you could put a Profibus or Profinet interface in there, but the accounting just doesn't work. And so with I/O Link, the interface is very, very inexpensive. And so you can have these, and because what's happening is, computing power and memory is getting so inexpensive, so small, so cheap, these devices are just getting smarter and smarter and smarter. And how do you access that data? Well, I/O Link gives you a way to do that. And so what we do is we think of it as the USB of automation, because it's a point-to-point communication. It's serial. You give your devices power and signal transmission over the same very familiar, inexpensive 3-wire cabling that we're all familiar with for AIs and AOs and DIs and DOs. Standard M12 connector. It's backwards and forwards compatible. An I/O Link master can just as well work with quote unquote dumb analog or dumb sensors below it. As I mentioned, it's field bus independent. But really, the whole point of all this is to get that extra data. I mean, a proximity sensor can tell you if, let's say it's on a conveyor belt, a dumb proximity sensor can tell you if the box is there or not. But an I/O Link proximity sensor will not only tell you if the box is there or not, but it'll tell you, is it a red box? Is it a blue box? Or it'll tell you how many boxes went by. Or if it's a temperature sensor, you can put really interesting things in hysteresis, or you could put, over temperature, things like this. All this extra data that people want and can use. That's kind of why we're excited about I/O Link and why people are installing it, because that's the use cases here. You take that data, you pump it out the other side via OPC UA. So there's an I/O Link to OPC UA companion spec, but they've also written companion specs for I/O Link to also JSON. I mean, that's incredible. Now you're talking about not just an automation use case for I/O Link, but you don't even need a field bus. I mean, just pump it out the other side via HTTP REST or MQTT if you wanted pub sub. In that case, we're seeing use cases for I/O Link even outside automation.
Now, the value of IO Link seems pretty straightforward, but some may still question its use in applications that require wireless communications. And that's where Cortigo comes in. This company has applications where they have dozens, even over 100, wireless IO Link devices all communicating together on the same network with 5 millisecond updates. And we'll hear about the technology in this clip with Gabby Donnelly.
IO-Link Wireless, as mentioned, is part of the IO-Link standard, and it was designed specifically for factory automation. It was designed not just for factory automation, but for control and monitoring, for sensors and actuators. It's a universal standard, an IEC global standard, which is part of the IO-Link standard. IO-Link Wireless specifically was launched in 2018. It has a very low latency. It's a latency of 5 milliseconds, which basically means that it's actually 3 subcycles of 1.6 milliseconds, 1.6 milliseconds between master and device, times 3 repetitions. And that gives us the latency of 5 milliseconds, which is suitable also for control applications. It has what we call ultra-high reliability, pretty much cable-grade reliability. And it's also important to mention all these requirements here are part of the standard. So in order to adhere to the IO-Link Wireless standard and be compatible with the standard and compliant with the standard, you have to basically have all these as part of your wireless protocol and your wireless devices. We measure the reliability based on the pair, the packet error rate. And this is literally 1 million times more reliable than other wireless systems. So the packet error rate, for example, with IO-Link Wireless is 10 to the power of -9, whereas with other conventional wireless systems, be it Wi-Fi, Bluetooth, Zigbee, it is actually 10 to the power of -3. So literally 1 million times more reliable than other wireless systems. And it's also scalable. It's scalable to support hundreds of wireless devices in a machine or in a work cell. We have some machines that we're developing with machine builders that have 300 actuators in constant motion on a single machine. And it's also a deterministic protocol. It's not a best effort protocol. So it's a guaranteed delivery between the master and the device.
So this is a first for me. So you're saying, all right, so typically when we think wireless and industrial automation, we have a few nodes, right? Or if it's a SCADA system, maybe we have 100 nodes, but that's SCADA, that's different. You're talking that you have hundreds of nodes, all with a 5 millisecond update rate on a single machine, all in motion?
Right, exactly. A great example for that would be, as I mentioned, the transport track systems or the smart conveying systems. You can have some of these systems, they can be like, the Rockwell iTrack system. It can be the B&R Copus Track system. It can be all sorts of systems from vendors out there that have these movers or shuttles, right, that are in constant motion, can get to speeds of 4 meters per second. Each one of those can have several actuators and sensors on each shuttle while moving on a single machine. That's a great example of the kind of scalability that can be reached. Other cases, for example, we've seen end-of-arm toolings where you have like this big tool or tray on an end-of-arm large robot where you can get even up to 50, 60 IOs right on a single tray or tool like that. And all that can be controlled wirelessly.
Now, we've covered a lot of products up to now. We've covered PLCs, networking, motor control, sensors, but what about HMIs? They're a critical part of many control systems. Well, over the years, HMIs have seen a lot of innovation, right? From HMIs that can do data collection and reporting to HMIs that serve up their graphics as HTML5 so you can look at them on your mobile device. But the one feature that really stood out for me this year was the new collaboration feature in the unified comfort panels. And let's turn to Ramey Miller from Siemens to learn all about that in this clip.
How does collaboration work? Collaboration is where we can take a screen element or a set of like a screen window, per se, and if that's something that needs to be shared or seen from another system, another device itself, you can actually, in the project, say System A is going to share this screen with System B, and System B is going to share a screen with System A. Or those two A and B systems can share a screen to a supervisory location. So what that does is that allows you to create those screens on each runtime independently, and it allows the other operating systems or runtimes access to those without having to re-engineer and put those into those projects. It's sort of like a sub-client within the project. So really giving a lot of power there. It's not just a screen control or screen interaction that you get. You also can share alarming information. So now a supervisorial system could be collaborating with 4 panel systems or 3 panel systems on the line. And if any one of those is if you've got this collaboration set up for the alarming, if any of those subsystems triggers an alarm or has an alarm on it locally, they're collaborating that alarm buffer up to the supervisorial system, and now they see the alarms are happening on the factory floor and something needs to be addressed. They can either address them right there, or or just tells them they need to go down to the factory floor to take care of it locally. But it is all controlled, and all that interfacing is shared collaboratively. So a lot of power coming into us from the collaboration standpoint.
Now, there's no denying that the investment in robotics has been outpacing all other categories of industrial automation over the last couple of years. And many companies are finding they have new fleets of AMRs and AGVs that they're struggling to keep track of. And that's where RTLS comes into play, real-time location systems. And we'll hear all about them from Nicole Luther here in this clip.
And what RTLS can really help you with and help our customers with is to find things. It's always interesting when I talk to customers, how much time they really spend on searching for things. Very time consuming and long search procedures. They lose their assets where, at the end they have to spend time either producing more or buying more. So it can really help them to find and keep track of their inventory. And then document everything automatically. So obviously there's still a lot of paper travelers out there. It can definitely help reduce that, monitor things, get an overview of your logistics procedures, your manufacturing processes, and also control and guide, whether it be people, whether it be AGVs or forklifts, as you can see here on the screen. So a huge variety of different applications that you can do with RTLS. Another example is AGV locating or forklift locating. There are requests for collision avoidance, of course, when you have high traffic areas and you have people, you have forklifts, you have AGVs. So all that, of course, needs to be coordinated in order to avoid accidents, and with the location data, we can, basically provide that information and say, okay, there's a forklift, there's an AGV, they come too close together, we can set an alarm, the system can stop or alarm, whether it be a person or can stop an AGV, for instance. But you can also optimize your routes and optimize your material flow.
With the increasing reliance on fleets of mobile robots, some companies are starting to struggle with the charging needs of these devices, with a third or more of their fleet spending hours each day just charging and not working. Well, one company came up with an ingenious idea to put those charging robots back to work and let them charge while they're working. And we hear about that from Noam Geffen from Kapow in this clip.
When you need to deploy also charging, you lose real estate in the warehouse. So you basically have less place to put your products in, and then basically you suffer from that. And we say, okay, what if in a miraculous way, we could basically achieve, first of all, a solution that runs 100% of the time for 100% of the fleet. Okay, and you can actually prolong your entire solution's life cycle while at it, okay, and reduce the cost of ownership. And of course, also, which is something which is less talked about, disengage the dependencies on traditionally inefficient power solutions. And this is basically where the thought about the Kapow Genesis came from. And our product is a wireless power delivery ecosystem for moving robots. Okay, and when I'm saying moving robots, I actually mean that. So our product is basically the only one in the market thus far that we know of that is able to power robots while they're on the go, so while they're in motion. Okay, so basically 100% of the fleet works 100% of the time. And the best thing about it is the solution is completely agnostic to the hardware, to the battery type, and the surface. It means that we can run on every kind of robot, okay, AGVs, AMRs, ASRS solutions, shuttle system, drones, what have you. We can work with every kind of battery solution that there is today, lead acid, lithium, supercaps, you name it. Let me just explain you how this magic happens. So we look at two sides, the robot side and the facility side. On the robot side, we integrate into the robot a small box, okay, which is called the Genesis receiver. Okay, the receiver is a very lightweighted device. Okay, it's around 1/10 of the size and the weight of a normal lithium ion battery. Okay, and it's integrated into the bot in a very smart way that the battery basically looks at that as a CCTV charger. Then on the surface of the robot, may it be on the bottom of the robot, on the side, on the top, whatever, we're putting the antennas, okay? An antenna, or in the Kapao lingo, it's called a sticker. It's a very thin and double-shielded aluminum foil, the antenna, which basically receives the power from the facility side system and then distributes it into the robot directly into the rail. Okay, again, not changing anything in the layout. On the facility side, we put the same kind of a sticker, okay, on the floor. Okay, it can be completely customized to how the bot looks like. It means it can be narrow, it can be wide, it can be long up to 30 feet, and can be short up to 2 feet. We even did a very cool application with a drone that basically reads barcodes for inventory inside the warehouse, and then we put this kind of a sticker up on the rail, so the drone never needs to land in order to get charged. So it gets charged while it's in midair, and basically instead of landing every 30 minutes, it lands every 3 months. The sticker itself delivers 500 watts flat, okay, to the robot. Why are we using this number of 500 watts? Because of most of the researches that we have done concluded that the average power consumption for a robot, okay, in the automation world as we look at it today, consumes between 100 and 120 watts, okay, on average. It means that if I deliver 500 watts, and that's the nice thing, I only need 120 watts to continue to power the robot as it goes, and the rest of it goes to charge either the battery or our own supercap solution on the robot. It means that I'm not a charging system, I'm a complete power delivery system. So it's both power and charging at the same time. Why is that very important? Because if I place those stickers in strategic places in the factory, in the facility, it means that only a limited number of stickers can power your entire fleet wherever it goes all the time. And that's the beautiful thing about it.
Aside from the latest developments in AMRs and AGVs, there's also another new breed of robots known as cobots, which are being deployed in a wide array of applications, from welding to machine tending. But with recent advancements in force control technology, they're also being deployed in a brand new range of applications, as we hear about in this clip with Connor Hughes of Flexiv.
Here's a demo of a Flexiv robot and a Flexiv gripper, which I'll comment more on in a minute, doing a really similar task. So you'll see it's going to pick up a USB cable that's kind of lying randomly on the table. It's going to grasp it with a gripper gently. And then with that gentle hold, it can kind of bump the USB against the edge of the charging strip here to reorient it to the right position. It can locate, approximately over the port. And then it can come down and gently touch the USB to that port and kind of just sort of move it back and forth slightly until it feels where it's supposed to go, and then insert it the rest of the way. So in this video, we have a different sort of application. This is like a surface treatment application, which is really another, we're looking at like a buffing head here that's like polishing a curved surface. And these surface treatment applications are really another clear-cut case where force control is super helpful. And so what you'll see is this polishing head is going to be guided back and forth over this surface. And as that happens, the gentleman and my colleague in the demo video here is going to be able to move that surface around and reorient it, and even tilt it back and forth. And the robot will continue to follow this path where it applies a constant pressure to this curved surface and can achieve the quality of polishing that you're hoping for. And so, to come back to this concept of adaptiveness, what we really mean when we say that is that we want a robot that is adaptive, needs to be able to handle variation and uncertainty regarding like the position of the workpiece or object that you're trying to manipulate. So in this case, we don't have to tell the robot, exactly where this object is that it's trying to polish. We can tell it roughly where it is. And then another component of adaptiveness is transferring learning between these different tasks. So if there were small variations or we had a couple of different types of workpiece that look like this that are similar, we don't need to reprogram the whole application to account for these small changes. Again, the robot doesn't need to know the exact shape of the object. So what it really does here is say, hey, I'm going to try to move downward until the polishing head comes into contact with this curved surface. And then I'm going to try to follow this back and forth motion across this area. And while I do that, I'm going to be in control of how much force I'm going to apply to the environment. So that's more or less how we would do the same type of task. You wouldn't need to really look at the CAD yourself before trying to figure out exactly what the curvature is of the object. You just say, hey, I'm going to press gently and steadily against this object and move back and forth along that surface. And so that's something that we can do with a force control robot that enables this adaptiveness. And then lastly, as he moves the object around, this really demonstrates that another benefit is disturbance rejection, we would say. So we don't need really, really perfect fixturing and rigidity, and we don't need to worry too much about things getting bumped or ending up in different spots, because we can use force control to handle these things by making the robot compliant, which is to say that using force control, we can make the robot respond to its environment in a way that's not totally rigid, right? It can continue to gently apply a force to the surface even as it moves.
With all the new robotic applications in our facilities, it didn't take long for the need to arise to have multiple robot arms working in the same area. But with current technology, that typically meant the second robot arm would have to wait outside of the area when the first robot arm was in that area. And that meant that second robot arm, it had a greatly reduced efficiency because it was not doing anything when the first robot arm was in the work area. That was until real-time robotics figured out a way to let both robot arms work in the same area without ever colliding. And we learn all about that from George Kondaris in this clip.
Our technology enables robots to compute those on their own, the same way that you or I just generate motion without thinking about it, right? We never think about where to put our elbow exactly when we're reaching into the fridge. We decide where we want to put our hand, and the rest of the stuff gets computed. And one of the things that I'm most excited about is how that's going to change the game in industrial automation. At the moment, if you want to automate something with a robot, you essentially have to manually pre-program that robot's entire motion. A human has to do the thinking for the robot about its basic spatial awareness and how it moves through the world. And we're changing that. We're going to get it to the point where the robot has a couple of layers of basic physical intelligence, can move around the world by itself, even in the presence of other robots, in the presence of moving obstacles, in the presence of unmodeled obstacles, and just be able to move around without hitting stuff. Just as basic as that could actually change the way that automation happens today. Very often you want multiple robots in the same work cell or in the same workspace. But as you say, the way that we program that today is that you set up these interlocks where only one robot is allowed in a volume of space at the same time. And a human does all the coordination in advance, does all of that work, and then kind of watches it happen a couple times, and inevitably is conservative about how the robots can move, because you're not going to be there at runtime, and there's always going to be some process variation. And so what we find is that typically when you deploy two robots, you only get like a 25% throughput boost in something like pick and place, right? You aren't moving twice as much merchandise in the same amount of time. You're moving 1.25 times as much merchandise because the robots have to wait for each other in this conservative way. But with our system, you just plug all the robots into the same box, and they can very finely move around each other, choosing their motions at runtime. What they actually do is they kind of reserve a little bit of space ahead of time, so the one robot sort of decides where it's going to go and reserves that motion through space, and then the second robot treats that as an obstacle to avoid. And we found that it can be more like 1.75 times the throughput. So there's a lot retrieved there, but what's even more exciting is you don't have to stop at two robots, right? We can support up to 16 in the same workspace. And so there's lots of automation tasks. Automotive is the most common one, where you want to maybe weld or put in bolts all over a car chassis, and there's a lot of holes and a lot of welds you want to make, and moving the chassis around is very expensive, takes a lot of time. So it'd be great to have just 12 robots working at the same time, and we can do that seamlessly without any effort on the designer's part.
With hundreds, maybe thousands of new smart devices added to our facilities over the last few years, it can be a daunting task to try to manage all of those configuration files and program files and store them somewhere safe, and then manage the change of them. Who changed what, where, and when, right? Fortunately, companies like Copia are here to help us with that. And in this clip, we learn from Adam Gluck about their new product, DeviceLink.
The amount of code bases, the amount of code that is running an industrial operation, has multiplied, over the years. And so whereas this might have been a small pain point before, we're now seeing teams, managing fleets and fleets and fleets of devices, thousands, sometimes tens of thousands of devices, across their entire operation, corporate operation globally. And it just is really hard. It's a really hard problem to solve. And that's where this tool chain comes in. But the big thing that we're super excited about, that we're talking about here, is DeviceLink. And it's kind of funny because you were saying, well, it's not just PLC, it's all these other devices. And actually, when we started with DeviceLink, we called it PLC Link. But then as we started talking to customers, we realized the scope of the problem was so broad that we weren't actually just going to be dealing with PLCs, where our source control product was really focused on rendering. Once we got on DeviceLink, we're really going to be focusing on a broad set of devices. And what that looks like is, how do you automatically back up these devices? And this really enables you to close the loop between source control and plant floor. So source control prevents you from shipping something that's broken, but DeviceLink and auto backup lets you catch it if something does get deployed that's maybe broken. So having these two processes together are really powerful. And so DeviceLink is really focused on this. And so this is really our Git-based automatic backup solution. And the goal of this is to bring visibility into this industrial change management. So if you're talking about those hundreds of devices, and this is something that kept coming up with our customers, is those hundreds of devices, they actually, people are still pushing changes to them. So even if you have great source control practices, you might have a vendor come in, or a technician, or someone who hasn't been trained yet, or someone who's just in a hurry who ends up pushing changes anyway. So even once we got this kind of source control and collaboration piece going, people are like, well, we love this and we think it will work, but we actually want to still catch things in case we mess up. So it's kind of a critical piece of that overall process. And then where Copia is strongly differentiated is that whole source control piece is tied to the backup piece. So you're actually kind of in the same space. You're using the same repositories. Development and plant management ends up being able to use the same repositories and the same kind of space for understanding what changed there. And it gives that strong visibility into like, hey, this is what we think is in production, but this is what's actually in production. And then you can resolve that, and figure out what's happening there.
With ransomware, malware, and cybercrime seemingly in the headlines every day, and the biggest of the biggest companies seem to get hacked over and over and over again, cybersecurity has to be on our mind these days, especially since so much of our industrial automation systems are networked together. So thankfully, the ISA started working on this years ago with other organizations, and they developed a standard known as 62443, and we learn all about that in this clip with Eric Kosman.
Without further ado, let me get into a very brief overview of what 62443 is all about. Back when we formed the committee, and this is a direct quote from some of our formative documents, we defined our scope as automation and control systems whose compromise could result in any of these situations that you see on the screen. And we have a catchphrase that we use very often, which is, if your system is not secure, you can't be sure that it's safe. And I think that we are, as a community, starting to come around. One of the presentations that I'm also working on at the moment is how the role of the automation engineer has changed and continues to change. There used to be automation engineers were concerned with automating single loops with largely analog technology, and the automation engineer's role today is much, much broader, and security is one of those things that they should worry about now that they may not have in the past. This slide shows the status of the various documents in the series. Let me just walk through a verbal description. It consists of 4 tiers or 4 categories. We have one general category where we have standards and technical reports that, as the name implies, speak to subjects that are general or common across the series. Moving down, the second category is the policies and procedures. We all heard about systems consisting of people, process, and technology. This is the people and process tier or group. The lower two tiers or categories here address specific requirements first at the system level and at the component level. The first one at the system level is a technical report that we publish and republish from time to time, which is basically a survey of security technologies with commentary on their applicability for industrial control systems. Then there is a standard 3-2, which is devoted specifically to how to do a comprehensive risk assessment for your automation system. And then 3-3 talks about the detailed technical requirements for security at the system level. Then we go down to the component level. Because as you know, or you probably know, automation systems are made up of pieces and components from different suppliers and assembled into a solution. So we have a 4-1 standard, which lays out clearly what a supplier of automation components or systems should have in place to ensure that they have a secure development lifecycle. And then we have 4-2, which basically takes the system level requirements from 3-3 and decomposes them into more detailed requirements for individual components. So last slide I'll leave the group with is the first thing you have to do is, if you're going to apply the 62443 standards, is understand those fundamental concepts that I talked about, or those pillars. The second item is understand your system level requirements. This is based on a risk assessment. That leads into characterizing your system under control, know the scope. The most important, possibly labor-intensive effort in this bullet is inventorying all the equipment and applications. I mentioned principal roles. Once you've got the principal roles, figure out what they're responsible for and identify their assignments. And more important than assignments or responsibility is accountability. Who exactly is accountable for what? Recognizing that the ultimate accountability for the security of an installed system is with that asset owner. You can't delegate that accountability really when you get down to it.
In this session, I covered some of the trends that I'm seeing as I prepare for the daily news show and as I talk to vendors each week on the product and technology show. But we've really only scratched the surface. I mean, there's advancements in condition monitoring, advancements in digital twins and simulation, advancements in machine learning and AI. I mean, there's so much more going on out there than we could cover in this one session. Well, I hope you enjoyed that episode, and I want to thank theautomationschool.com for sponsoring this episode and making it possible. If you know anybody who needs PLC, HMI, or SCADA training, please mention theautomationschool.com to them. I also want to thank all of the vendors who came on the show this year. We had 52 shows this year, and it's hard to think of all the vendors we need to thank, so I just want to thank them all. It's always a pleasure. And, I learned so much by having these vendors on. I hope you do too. In any case, if you want to join our community, you can do so over at automation.locals.com. And of course, I do want to wish you a very happy and safe New Year's Eve and New Year Day. Oh, and don't forget, if you get a chance, please visit theautomationblog.com and vote in our first ever Audience Choice Awards. Let us know who your favorite vendors are and favorite products are. It really will give me some great guidance going into 2024. So with all that said, I do want to wish you again a very happy New Year, a very happy New Year's Eve. Be safe, be happy, and be healthy. I also want to encourage you all to stay courageous and stay fearless. And until next time, my friends, peace.